Pretty brutal area problem this. We've got a thin wire of length A centimeters, so got that as the perim. Is bent to form the perimeter of a pentagon. That's an irregular pentagon as well, as we'll see in a sec. And these are the names of the vertices in which BCDE is a rectangle and ABE is an equilateral triangle. So let's just draw this. So here is our rectangle on and a equilateral triangle. Now BE is the common vertices, so that's BE. This must be A then, and therefore this is going to be C and D. Now CD is X, 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 and we don't know what that one is. We're just going to call that one Y. Okay, so what we're going to do is find A of X in terms of X. Now this is a little naughty, okay? This question really should say find A of X in terms of X and A, okay? Because I did this problem and spent a while trying to think about how I'm going to get it only in terms of X, and it's actually not possible. And you can see here that the tip is that the maximum area is given in terms of A as well, so it's not an actual number. But you'll never be able to find it A of X in terms of X only, and it really should say in terms of X and A, and that's bad form by Cambridge, because whenever you see this is in a VCAR exam or a VCAR methods exam, you're not allowed to have any other variable that it's in terms of. It can only be in terms of X. Okay, so that's a bad slip up by them. All right, anyway, enough of me berating them, and let's get on to finding A of X. So what we're going to do is use the fact that I know that A is equal to 3x plus 2y. So the perimeter is equal to this side, this side, this side, this side, and this side. Now let's get it in terms of A and X. So we're going to say that 2y is equal to A take 3x. Y is equal to A take 3x on 2. So I know that y is exactly the same as A take 3x on 2. Okay, now let's get our area functions. So we're going to say that A of x equals, and it's going to be the length times width, that's the rectangle component, plus the half base times height of the triangle or equilateral triangle component. Okay, so let's do the length times the width, which is simply going to be x multiplied by A take 3x on 2 plus half the base, which is half x, multiplied by the height, which we can get from Pythagoras' theorem. So I'm just going to draw that. That's going to be x. That's x on 2. And if I use Pythagoras' theorem, go through the steps if you want yourself, it's going to be the hypotenuse squared, take away this side here squared, which is going to be x squared on 4. So multiplied by this thing here, which is root x squared take away x squared on 4. So that would be serviceable enough to get me a mark for this question here, but what I'm going to do is just further engage in this, and to answer B, I really need to get this into a form that I can recognize, because basically it's a parabola, okay? And I need to get it into a form that allows me to state the allowable values for x. All right, so what I'll do is I'll further engage in this by expanding this. So I'm going to say that this is ax take away 3x squared, and both of them are going to be over 2, plus a half, or let's just call it x on 2, multiplied by this thing here, which is going to be the square root of 4x squared over 4, take away x squared over 4. So I'm just finding a common denominator there. Ax on 2, take away 3x squared on 2, plus x on 2 multiplied by, so this is going to be over here. I'm just going to jump through a few steps here. It'll end up simplifying to 3x squared on 4, which then I'm going to root the 3, root the x squared, and root the 4, which will take me to root 3 x all over 2. Now let's go ax on 2, take away 3x squared on 2, plus, we multiply these out, root 3x squared on 4. All right, so the parabola is really starting to reveal itself now, and what I'll do is find a common denominator, 2ax on 4, take away 6x squared on 4, plus root 3x squared on 4. All right, still going here. What I'm going to do is yank x and 4, so x over 4 out as a common factor. I've got 2a, take 6x plus, what's that, root 3x. Yeah. All right, so that is a more refined version of my area function. So that's part A done. State the allowable values of x. Okay, well, looking at our diagram, at a base level, x has got to be greater than 0. Okay, but also y has to be greater than 0 as well. Okay, so that other variable y has to be greater than 0. What have we called y? Y is this over here. So let's just replace y with that. That's going to be a take 3x on 2, I think it was. A take 3x on 2 has to be greater than 0. A take 3x greater than 2. Negative 3x greater than 2 take a. Running out of room here, x less than 2 take a over negative 3. Now that doesn't seem right, and you can maybe spot my mistake here. Bad form, Mr. Miller. This one here, a take 3x on 2 greater than 0. Scrap that stuff there. A take 3x greater than. When I multiply 2 by both sides, that's still going to be 0 there. Negative 3x greater than negative a, x less than a on 3. Okay, so they're my two values there. So x greater than 0, x less than a on 3. Okay, so the final part of this question said, show that the maximum area is a over 2, or a squared over this. All right, so what we need to do basically is know that, and I'll quickly sketch this up on GeoGebra, so I'll just drag it across. So that's the function there that I've sketched, that's a of x there that I've sketched, and you'll note that basically, as I increase this a value here, so too does the maximum area, and it's going to be, the maximum is going to be the midpoint. Okay, so the midpoint between 0 and 2 point whatever it is. So let's work out what the midpoint is. So it's going to be 0 plus whatever the other x-intercept is. Now, what's the other x-intercept? It's going to be this one here. So x is equal to 0, or 2a takes 6x plus 3x, root 3x is equal to 0, which is going to be negative 6x plus root 3x equals negative 2a. Grab x out as a common factor. Negative 6 plus root 3 equals negative 2a. X is going to be negative 2a over root 3 take 6. All right, so what I'm going to do is, that's the other x-intercept there. So it's going to be 0 and this value here, which is 0 plus negative 2a over root 3 take 6. and the midpoint is going to be found by just dividing that by 2. So I've got the first x-intercept here, the second x-int here, and I'm dividing by 2 to find the midpoint there. So that's going to be negative 2a over root 3 take x, all divided by 2 is the same as multiplying by a half, and it's going to be negative 2a over 2 root 3 take 6 with some brackets around there. Okay, so that's the x value where the maximum occurs. Now what I've then got to go on to do is stick that x value into the area function here. All right, now I don't think that that's an easy one to do. I think that that's probably a tough substitution to make. Let me just think about that. Okay, now because this question actually is a show that question, I've really got to show the move that gets this out. Otherwise, I'd usually say just jam this thing into the calculator. So we're going to have to do this, and it's pretty ugly. So just erase a bit of space here, and I'm just going to continue over here. So I'm going to do a of this value here. Now what's going to happen also is these 2's cancel out. So a of negative a over root 3 take 6 in the denominator equals. All right, so let's sub it in. So I'm going to put it in. So everywhere I see an x, I'm going to replace it with this thing here. So I'm going to go negative a over 4 root 3 take 6 multiplied by 2a take 6 negative a over 4, no, not 4, over root 3 take 6. All right, where are we? Plus root 3 negative a over root 3 take 6 and close brackets. All right, so it looks pretty nasty, and I don't know how you'd expect at this point to show that, but we know we've got to get there, so we've got to trust that we've done this correctly. So I'm going to go negative a over 4 root 3 take 6 multiplied by 2a. Now this thing here, let's rewrite that as plus 6a over root 3 take 6 plus minus root 3a over root 3 take 6. All right, equals negative a over 4 root 3 take 6, 2a plus 6a take root 3a over root 3 take 6, because that's my common denominator. Okay, now what I think is going to happen, these will cancel out somehow. So what I'm going to do is pull out a common factor for this. So it's going to be negative a over 4 root 3 take 6, 2a plus, no, not even a plus, I'm too anxious with that. It's going to be negative a. Now that's going to be root 3, so negative times a positive is a negative. Root 3 takes 6, here it is, okay, over root 3 takes 6 in the denominator, and lo and behold, they cancel out, giving us 4 root 3 takes 6, 2a take a is simply a left there, multiply that out, you get negative a squared over 4 root 3 takes 6. Please tell me that's what I was going to show that. 4 dropped some brackets there, so go back or track back and replace some brackets in. All right, we're still going. So what they've done with this is they've also pulled out a negative sign equals negative a over negative 4, 6, take root 3, and then cancelled out the negatives to make them both positive. So it's a squared over 4 bracket 6 take root 3. All right, please tell me that's what I was supposed to show. A squared 4 bracket 6 take root 3. All right, so there it is. All right, that's a really, really tricky problem. And you've seen me make a few mistakes along the way and struggle my way through that one. So hopefully it gives you an insight into the level of difficulty of this problem. Put that on your Year 12 SAC. Hardly anyone gets anywhere close to getting this one right, or even part way through it. So yeah, no wonder you found that one a little bit tough, and there's probably an effort at explaining that. The algebra is fantastic, but even at a Year 12 exam, more than likely a lot of this stuff would probably be highly calculator based as well.